Hello, this is Kevin Bowersox, creator of the blog 2Thought. In today's tutorial, we're going to explore the Java Persistence Query Language, also known as JPQL. JPQL is an object query language which is similar to SQL in its syntax, but instead of dealing with column names and table names, we're dealing with class names and field names. JPQL is part of the JPA specification. It can be used to retrieve data using our object model. As always, I invite you to follow along with today's tutorial. The code that we'll be starting with can be downloaded from the post on the 2Thought blog by clicking the GitHub repository, and that will give you the source code we're going to start with. From there you can follow along with my instructions and eventually have a working code example. So let's begin. I'm going to head over to STS, and within the project you'll notice that I have created a test util, and basically what this test util will do is populate our database with about 30 examples of posts and post parts. So we've been working with these posts, which is basically representing a blog post in our object and data model, and we just want to create some data. So I'm just going to run this and give it a second. We can see we had some data inserted, and now we'll check our database, and we can see that in our post table we have a few example posts, actually quite a few. And then within our post part table we have some more example posts. So this is the data we'll be querying against using JPQL and the object model. So let's head back to STS, and the first thing we'll do is within our test package we'll create a new test, and I'll title this test JPQL test. And now I'm going to access one of our other tests so I can grab some configuration, and we'll place that at the top of our class. That's just pulling in Spring, which is setting up all of our JPA configuration. Now I'm going to include an entity manager, which I can auto wire using the persistence context annotation. And it helps if I spell that right. There we go. So we have our entity manager wired, and now we'll run a simple query. And the entity manager has a create query method, which we can provide a JPQL statement. So here I'm simply selecting all of the posts within the post table. Notice I'm using a class name here, and then I give it an alias of P, and then I can also simply say select P, which will grab me everything in the post class. Then I can have a list of posts that will get returned from the query when I call the getResultList method. So I'll import the list. We're going to get a warning that this is not type checked, because the getResultList method, see what that returns. It's going to return a list, and it's not generic, it doesn't have a generic type. So it may not give us the right type of entity back to go in a list of posts. In our case, we know it will, but in other cases, in live production code, we may not be so sure of that. So I'm just going to print out the title of each post. So let's run that. Whoops. So you can see, I'll pull my console window up. We just returned all the posts in the post table. Now let's take a little further look at the type checking. So let's switch post to post part. That's a different entity within our object model. And now we should probably get a class cast exception when we run this. And as you can see, right there's our class cast exception. That's because this is a list of post parts getting returned into a list of posts. Now, one way we can deal with that is by executing a typed query. So we just switch over to a typed query, and then when we call the create query method, we provide the type of the object we expect to get returned. And now we can save that, and we need to generically type our typed query, so we provide it with the generic arguments. And we'll also still need to switch over to a post here. We'll execute, and this time we should have no problems. So I would recommend using the typed query whenever possible. It allows you to strongly type your posts. It allows you to strongly type your lists that are returned from the query. Using JPQL, we can also grab composite objects from our entities. So for example, in our object model, if we look at our entities, we see that the post class has a post part composite object, and that post part object has a body. Let's retrieve the body of the post part for a post. So I'll head back to our test, and we'll create a new test. Call this composite test. Within this test, we'll create a new typed query, and it'll return a post part. And we'll create our query. So here you can see, and I need to provide a type since we're using a typed query. And there we go. So here you can see that I'm selecting the post, and then from the post I'm grabbing the post part. So we should get returned a list of post parts. So we'll iterate through that list. and print out the body. Okay, so let's look. We can see that we're getting the body of each one of the posts because we have grabbed that composite object within our entity using JPQL. In our final example, I want to demonstrate one more piece of JPQL. So I'm going to create a new test. And within this query, we're going to return posts. And we're actually going to stipulate a conditional in this query. So I'm going to select the post from post P, give it the alias, and then where the p.stamp.author is equal to, is like a variable which we'll introduce in a minute. And just like in SQL, you need to use single quotes for your string literals. And let's see if we can wrap that. So here, this query will grab each post where the author name is like a certain name that we're going to provide. You'll notice here I'm using post.stamp.author. Stamp is an embeddable, and then author is a field on that embeddable, so you can see I'm traversing across that. To get the input, I'm going to use a scanner so we can actually provide that input. So I'll import that. And we'll just give a little text. I should probably make a new instance of that. And now we're going to introduce our string name. And we'll take the input in. And what doesn't it like here? Oh, once again, I forgot to provide the class because we're using a typed query. So we'll save that. Now we'll iterate through. We need to execute our query. We'll get the result list, and we'll iterate through the posts and print the title. I'm going to see if I can break this string up some for us. Okay, so let's give this a shot. It's asking me to provide a name. So now we get all of Kevin's posts. One thing you'll notice, I have a few of these posts that say this is a secret post. That's in our data load. So let's modify this query so we provide some security for the secret post. Let's imagine that's a post that is internal to me, and this query is allowing a user to grab the post for a specific author, and we want to restrict them so they do not see the secret posts. So to restrict them, we can add another clause to our where clause. looking at p.title and making sure it's not like secret. So we're just going to make sure that the title doesn't contain secret. We should restrict them in this manner. So we'll run our test. And we'll provide the author name. And now we can see we don't see any secret posts for Kevin, which is good. It's working like we expected. Let's run this test one more time. And this time I'm going to try to inject some SQL, or in this case, JPQL. So you can see here that I end the other statement and then begin a new predicate, looking where title is like a wildcard, and that's going to complete with the string literal we've created. Now you can see, using JPQL injection or SQL injection, I was able to retrieve the secret posts which we were supposed to be protecting. JPQL provides a means to deal with this situation. We can provide positional or named parameters in our SQL. So I'm going to modify this statement to add a named parameter, and then I'm going to set that parameter to our local variable name, and I'm actually going to add the wildcards here. And let's give this a shot. We'll run it once just to see if it works, and then we'll try to inject the SQL with it. So this time, when I ran using Kevin, we do not receive any secrets, so that's good. Let's try running it again with our SQL injection and see what happens. Okay, you can see we didn't return anything, and let's look at the actual SQL that Hibernate executed, and we can see that it didn't even consider those additional query statements that we tried to inject, which is providing us some security. Whenever you're using JPQL, make sure that you're using parameters, whether they be positional or named. I prefer the named, because if we would have multiple named parameters in the same statement twice, we would only need to set the parameter once, whereas the positional parameter would need to be set multiple times. Also, using the names, it's a lot easier. You don't have to remember what position a specific parameter is in. It's definitely a lot better to use the named parameters. Another reason to use the parameters in this case is because it will give you performance upgrades. When you're dynamically creating SQL, you're not only creating a security risk, but that SQL statement basically needs to be generated every time. We'll get some performance gains using a query that includes the parameters, because the statement won't need to be generated every time. So that wraps up today's tutorial. I hope you found it useful. I'm exploring JPQL. And we're going to continue to look at JPQL in our next post, maybe look a little bit further at things like joins, and some other complex language structures that we can use. And eventually we're going to rule this up and then look at Spring Data and the benefits it provides, but I think it's important to have a foundation so you can understand what Spring Data is doing for us and the work it's performing. And a lot of it is just making it easier to create these statements in JPQL, at least on the retrieving data side of things. Hope you enjoyed it. Until we meet again.